Okay, you guys are live.
Okay, my name's Jim Bryant. I'm going to give you, along with we learned about the material that's been declassified thanks to my lawsuit. Yes, I sued the Navy for the information on Thresher. Served on 3 Thresher-class submarines, commanded Guardfish. Steve is a naval architect. Want to give a 30-second?
Of course, from Naval Shipyard after I graduated from what was known as view ships, and some of my assets periodically dove on Thresher's wreckage and Scorpion's wreckage on the bottom.
And Fred is
Pertinent fact,
okay, and we have
okay, go ahead.
standard criteria. We're not the government. Some of the term qualified people under submarine. ASW means 2 things. It can mean auxiliary seawater system, or it can mean anti-submarine warfare. Ship service motor generator is important. Rotating machinery battery to AC power. And then down here, you've got a ship service turbine generator. The ship service motor generator is main coolant pumps. They remove all the hot stuff out of the reactor core, move it into the steam generators so it can create steam. It's very exciting class because it was quiet, it was fast, it could go routine test. This is not a special test or anything. It's not operational. It's a routine test dive to test the hull after an overhaul. And until I got involved, only 19 pages of testimony have been released. And after getting stonewalled by the Navy, I finally decided to sue them. And now we've got maybe about 3,000 pages of information. Now, I think the Navy, they did not give me whole blank pages of redaction. The group here can understand it because we're submariners, but you folks who don't know submarines would not be able to understand it. And so I will definitely be challenges to the redactions. No cover-ups, no smoking guns. And here's the key formula, right here. The key formula is no one realized the danger of going almost doubling the test depth of the submarine. And all of these things, procedures, mindset, all of that, no concept of what the real danger was. Also, the deep dive test was just not done right. It was very unsafe. Admiral Rickover, Director of Naval Propulsion, he had a procedure that could have saved Thresher using emergency propulsion, and that was not approved for Thresher. And Steve will talk a lot about crew training and officer experience. Now, everything below 800 feet, operating is classified. Even chopper, which we all know went to 1,000 feet, it's an open literature. But the Navy, if you show that to the Navy, they'll say that's classified. I mean, Thresher class were gone a long time ago. And in 1990, they declassified, they released a book to declassify the test depth of Thresher as being 1,300 feet. But they reclassified that again in 2009. Not sure what it is, but respected literature, which we quote, not our own knowledge, is 1,300 feet. And that's important because that's almost twice the test depth of previous submarines. They went from 700 feet to 1,300 feet.
This is a timeline, and like I was saying to a gentleman at lunch, you got to take it in the context of Sputnik. The Soviet Union had put Sputnik into orbit. In the United States as a country, obviously DOD, Capitol Hill, everybody else, a lot of angst. So around the time that the ship's keel was laid and she was designed, you had a satellite orbiting. 3 years and 3 months later, she was commissioned phenomenally fast. A year after that, she did explosive shock testing. A lot of you folks have heard about shock trials on the aircraft carrier board. That's a requirement for all new classes of ship. After that, in 1962, she entered the shipyard where she was built for a post-availability, or post-shakedown availability. During that time frame, both the CO and the XO were transferred from the boat, and 3 months later, she commenced sea trials and she was subsequently lost. Another thing to bear in mind, and keep all this in the back of your mind, 6 months before Thresher was lost, we had the Cuban Missile Crisis. Many of us lived through that.
Okay, test depth, collapse depth, very important understanding. Okay, test depth is the maximum submarine operating depth. It can go deeper, but you need special permission and special circumstances. It's also the depth of which you have to send a submarine to test the pressure hull. The only way you can test the pressure hull of the submarine and all the external cabling is to go to test depth. Except for no experts in here going to counter me. You should. The Germans had tanks, had pressure tanks for their submarines from World War II because they couldn't get deep enough in the Baltic to test them. But we don't. So collapse depth is a 1.5 safety factor. So that means that The calculated collapse depth, you're good to go. You're guaranteed to go to 1,950 feet. And all seawater systems in hard tanks subject to sea pressure on a submarine are tested to this collapse depth pressure. Everything except for the pressure hull and terminal cabling, 1,500 feet.
Thresher was an improved skipjack class in that she had the same S5W reactor, propulsion turbines and the like. She likewise had a teardrop, what they call a teardrop shaped hull. She had the same type of sail, fair water planes. And she was at the time designed to be and proved to be the most effective anti-submarine warfare platform in the world.
I'd like to read some. Let's talk about the key things that made her the best anti-submarine warfare platform in the world. First thing, here in the bow of the submarine. On previous submarines, they have a torpedo room up here. They have torpedo tubes sticking out. Well, they wanted to put this huge spherical active passive sonar up there. No room. So they moved the torpedo room back to the center of the ship. And they had this large conformal array. Then to make it quiet for these, they sheathed the whole bow compartment in a sound barrier material. And that plus a lot of sound mounts, a lot of rafting and machinery. The whole propulsion machinery was on rafts and sound mounts.
This is an inboard profile of what Thresher looked like. I won't get into the compartment. You can read that. She had a sonar sphere that Jim was just talking about. And basically the ballast tanks, the MBTs were the blue tanks. They were wraparound tanks. If you were to slice the boat in half or in a section, she was a circular cross section. That dove the boat. To get the boat to trim out and find equilibrium to hover in the water column, you had the red tanks, which were considered part of the variable ballast tanks. You had forward and aft trim that allowed you to bow up, bow down, and then you had the auxiliaries in the negative tank. The water through these red tanks, the variable ballast tanks, was pumped in and out by the trim pump. And if you had water in the bilge or you wanted to get rid of the contents of sanitary tanks, waste oil, it was done with the drain pump. Both the drain pump and the trim pump were the same make and model. They had the same oomph. We'll get into that in a little bit.
The ballast tanks open on the bottom, vented on top, make you submerge. Okay, in order to sound quiet the submarine and put these extra rafting and sound isolation mounts in, they had to make it bigger. They had to make the submarine longer, had to make it wider. And you can see up here, it got to be heavier. And so they wanted to keep the same speed. Speed depth, very important. So what they did is they looked for ways to reduce drag. They even ground down the welds in the ship to make it smooth. The biggest one was the sail. They made the sail much smaller, and they lost some mass on that, but they only reduced the speed by about a knot.
This is sister ship to Oscar, Portsmouth Naval Shipyard. It was there when I worked there. During the availability, that Thresher was subsequently lost out of. Being the first of the class, they were doing some design adjustments. Not that the pressure hull had problems, but they were worried because this class boat and all the nukes tended to go to their maximum operating depth so frequently compared with the old diesel boats. They ended up stiffening up flat plate bulkheads because they were getting worried about fatigue. They replaced major components like the trash ejector, new mass. They completely ripped out and complete the freshwater side of the main condenser system, including the pumps. They changed a big job. They changed what Thresher was built with, a synthetic hydraulic oil, which was a failure. They put it back to a petroleum-based hydraulic. And the boat, just before she went into the availability, I was telling you, had explosive shock trial testing. What they did was they surveyed the boat, made up a work package of things that had to be fixed. The problem was as the availability kept progressing, they found more and more things that weren't listed, and they had to keep fixing it. And that occurred right up to a few weeks before the availability ended. The boat went to sea.
Okay, the biggest job on Thresher was to put in a passive ranging system. I could go for hours on technique and sub-rock and all that kind of stuff. But in order to do that, they had to put these hydrophone arrays on the stern plane, into the horizontal stabilizers and the ballast tanks. And they rearranged a lot of piping and a lot of things. And the arrangement of all this piping, of this critical piping here, becomes important here later. There were no survivors, obviously, because the submarine had sank. And so there were no electronic recordings, no magnetic tapes. The SOSUS, we'll go into SOSUS in more detail, but the acoustic signature of Thresher was recorded on paper grams. The main source was underwater telephone, and the witnesses on the escort ship Skylark, and of course people that were involved with it. Now this on the left, this is Skylark, submarine rescue vessel. It escorts submarines out on sea trials. This is an underwater telephone that both Thresher and Skylark had. This is not radio. How many people in here are talking underwater telephone? Good. So you know how bad it is. It's, you know, you get, not only do you get the kind of static stuff, you get the reverberations, you get sea life interfering with you, you get own ship's noise, very slow means of talking back and forth. Very slow means and sometimes confusing. This is SOSUS, a key element of this whole study. Here you've got 40 hydrophone array. Get it laid across a continental slope at the right depth to collect the best sound from submarines. It's cabled up to a naval facility. This cabling goes into all of these, it's processed and go to these machines. Each of these machines is a beam that's formed by this array of about 3 to about 10 to 13 degrees. Each one of these paper is rolling up electrosensitive paper. The stronger the signal, the darker the line. And if all these things line up, you got yourself a noise source out there to evaluate. Bruce Rule. Bruce Rule is important. Bruce Rule was a reserve lieutenant in charge of analysis for the SOSUS system for the whole Atlantic Basin. They picked him to analyze the Thresher SOSUS recordings and to testify before the Naval Inquiry. He's also the one that took him a long time, thinking back on it, about 2009, says, you know, there were no SOSUS indications of flooding on Thresher. So there was no major flooding. There was no big pipe flooding. That water going out, hitting the hull would have caused resonance. It would have caused major lines on Thresher. So he analyzed, testified in court, spent 42 years in the Office of Naval Intelligence. And then in 2017, he called me up and says, you know, Jim, you know, I'm an old man. I need to tell this story. And the Navy won't tell it. So he wrote a book. And he says lots of interesting things in that book. There's most of it confirmed by what the Navy has now released. So it would have been secret. The Navy didn't really touch it. Okay, these are the SOSUS stations around the Atlantic. Most of these guys, all these guys on this side of the ridge detected the implosion of Thresher, equivalent to about 22,000 pounds of TNT. Now Shelburne was close enough, she actually got the main coolant pumps. And here's a description, here's a situational chart. One thing, the whole Gulf of Maine is shallow enough so the Skylark can make, especially the crew, the submarine sank, was on the bottom. Could not do it with the deep dive pump. So Thresher comes out of Fortress Naval Shipyard, rendezvous out here. That's a good placement because I got an unclassed message. Navy. They get what they call shallow ops. They stay above 400 feet. They go fast. They operate everything they can operate there. Cycle valves, do all that kind of stuff. Shallow, where the Skylark could rescue them. Then they proceed down this canyon and go out to this rendezvous site here. Now, they got blade rate. You know the blade rate, I talked to you afterwards. But she came down the canyon, the SOSUS array got some blade rate. But during the deep dive test, Thresher did not go above 12 knots. And that's kind of unusual. There were no machinery except for the fast speed main coolant pumps. And this is very close, 30 nautical miles, 50 nautical miles is very, very close to a SOSUS array. And that's about the approximate orientation.
Okay, what we found based on the testimony was there were some issues with design, which we'll get into, quality assurance, which we'll get into, training and crew personnel turnover, and basically some of the design codes were antiquated for a boat that could dive this deep. But basically the Navy did what they knew. Next slide. Okay, one of the things, for example, that was antiquated was there was a lot of runs of piping through the ship, and I mean a lot of runs, that saw full submergence pressure. So if they were at 1,300 feet, they saw 1,300 feet of pressure, even to the point of where you use water to flush the heads if you were doing it with about 600 psi. Next slide.
My research said they didn't flush the toilets much below about 300 feet. Otherwise, they got to be really excited.
Okay, Thresher during the PSA, Thresher had a tremendous number of turnover of, especially the wardroom. The CO and the XO were relieved largely to move on to more senior positions. The new CO and XO came in, but they had no Thresher class experience at the time. That was just Thresher, permit, and plunger in service, and there was just no way to get that type of training. Bupers had a goal, and they were aware of the fact that they were poaching heavily on Thresher's wardroom, officers' wardroom. And they wanted to make sure that Thresher had at least 6 nuclear submarine qualified officers in their wardroom. And in fact, Thresher had 7. One was ashore due to an emergent family issue that he was at the hospital. But so she was lost with 12 of her 13. Basically, because there were so few people that were experienced, they had to load up on the XO, who was also designated by the CO as being the sea trial test director, but he was also doing navigator, ops, and weapons because they had so few qualified people on board. And in fact, some of these people had just reported to Thresher. It was the first time that they were on a submarine at all. They had come out of either specialty school or sub school. So she had, with respect to the officers, very, very thin experience levels. She was a good crew, don't get me wrong, but the training infrastructure, because they fielded the Thresher class so fast, the training infrastructure wasn't very good. So basically, there were no, the documentation was not what it needed to be. As Jim said earlier, because of the PUFs installation, they completely replumbed quite a bit of the auxiliary machinery space in the engine room for the high pressure air, the fresh water, the hydraulic oil. All that stuff had to be relocated because they had to relocate the air banks. A lot of configuration changes, and what that means is as you move those pipes, the key valves installed on them go with them, and the crew had not have time to get re-familiar with where that went. Basically, that should have manifested itself to the crew. They did 2 fast cruises, and one of the fast cruises, they simulated a leak from one of those systems that was perturbated in the engine room, and it took them 20 minutes to find and isolate that leak. At test step, that would have been catastrophic.
Fast cruise, supposed to be fast to the pier. What you're supposed to do is get all the shipyard off. You get the reactor up, take off shore power, you simulate getting underway, you rig the ship for dive, close all the hatches, simulate all that. Did not happen on Thresher. They had shipyard people on board. They had nuclear test engineers on board for 8 or 9 hours. They had workmen coming down working on stuff. And things were breaking. A lot of stuff was breaking so fast, the crew had to spend a lot of time working on it rather than doing training evolutions and working on things. And in fact, they had a big reducing valves, as Steve will go through later, fail because of a dirty air system, and they secured the fast cruise until they got that fixed and a number of other items fixed, so they went back in. The chief engineer recognized that his engineering department really needed more engineering drills in their propulsion plant, their reactor plant. The captain talked him out of it. Says, no, we don't really need that because they wanted to get this thing moving. Where did they want Thresher? They wanted it looking for nuclear submarines of the Soviet type. They didn't want it playing games in shipping, right?
Okay, training tools were limited because Thresher was fielded so fast that they never had an opportunity to set up what we call today shore-based trainers. They didn't have anything to mimic how Thresher handled. They didn't have anything especially to deal with how fast water would come in with her diving twice as deep as a previous class as a ship. So the damage control trainer was reflective of much shallower diving boats. At the time, the reference material that the Thresher was issued was not up to date, and that the ship's information book didn't reflect the ship. And I can get into that later on if there's a question. And at the time, there was no such thing as what most submariners know as an SOE, a safe operating envelope, which is this right here. Basically, what it does on the shallow end, it tells you how to prevent trying to broach if you're in a hostile situation. But more importantly, when you're deep, it tells you what to do or provides you visual guidance as to how to avoid an inadvertent depth excursion because you're going too fast and you will suffer a stern plane jam.
They had several major failures of silver braze joints. Silver braze is a really neat thing. It's 10 times cheaper. It's faster to do. You get it tighter places, but and it's just as good as a weld as long as you get it done right. And a hydrostatic test will not prove that joint is going to hold. It's all about bonding. And they didn't get into the ultrasonic test routine until early 1962. Remember, Thresher went to the overhaul in the summer of '62. So they tested all the joints that were worked. They were taken apart and put it together again. They only tested 145 of the joints that were not worked during that overhaul. And you just can't find a problem unless you ultrasonic test it. And look at some of the numbers here. Look at the numbers here on the potential for number of joints that could have failed the bonding test. And why do they not do that? That is because senior leadership, I mean the top admirals in the Navy, thought if that silver braze joint originally made went through 40 deep dives, which Thresher did, went through a shock test, went back into overhaul, they checked to make sure the metal was right, another hydrostatic test, it was good to go. That would not be prudent in today's thoughts. You take a look at the skipjack number of joints tested that failed the bonding test.
Okay, the submarine itself, this Thresher wasn't based upon any kind of casualty analysis that back when she was designed. The flooding control surface failure was not considered in the design until the summer of '62, which is a year after the boat was commissioned. What they did when they started doing casualty studies, they realized that all of a sudden flooding was a real serious problem. When you went twice as deep, you flooded quite a bit faster. And they learned that the air bank blow rate, in addition to the air bank volume that they designed it to Thresher, was insufficient. The blow rate was not specified in the design, and they used the same blow rate, as it turned out, that they designed into earlier submarine classes such as Nautilus, which dove half as deep. They also found out, which they knew, they suspected that a stern plane jam was a very serious thing. Obviously, you could dive below your test depth and go to collapse depth very quickly. Okay, on the blow rate, the system, basically because they fielded Thresher so fast, there were a lot of systems that were not reviewed for performance at the much deeper depth she operated at, one of which was the high pressure air blow system. They did not have the time to do an R&D and and upgrade a lot of the components to a higher pressure. So basically what they did was they did put in 4,500 pounds of air into Thresher's air flasks, but they immediately reduced it back down to 3,000 pounds. But they designed it they sized the air banks to diesel submarine criteria, which was to surface twice from periscope depth, not test depth. Shoot all your torpedoes and keep enough air left in the banks to operate some of your pneumatic valves and all on board. Okay,
by design, Thresher was not designed to surface from test depth unless it had nuclear propulsion. That means if you lost nuclear propulsion and you were heavy for some reason, flooding, you didn't trim right, whatever, that means you had a reasonable chance of losing the ship. Okay, so what can cause common causes back in those days of losing propulsion? Stern planes jam dive. If your stern planes are jammed and dive, if you go forward, you go down. You have to stop. Or an automatic reactor scram, a safety on the reactor. Okay, the procedure back then was you had a reactor scram, you secured all steam supply to the engine. You shut the main steam stops. That meant you lost your ship service turbine generators, which means the only AC power you had was through your ship service motor generator. Here's this Axine, Dean Axine, Admiral Axine, had to be an admiral, shaking hands with Wes Harvey, the second CEO. He testified in court, and he said basically the trim and drain pumps were useless. They used diesel boat criteria. Diesel boats didn't go to test depth very much. They didn't worry about moving water out of the submarine at test depth. So they only had a couple of gallons a minute flow rate at test depth. And they had a blow system that, if worked right, could compensate for about a 1-inch leak. But that blow system failed, and Steve will go into that. And they didn't even test the blow system at depth. They just used the blow system to get from periscope depth up on the surface, and they used low pressure blowers to fill the ballast tanks with air. Okay, we got some new information from the Navy and equipment and the main coolant pumps, and we're being in fast speed and a rapid descent to test depth. Okay, look at this. You got 2 deep dives scheduled. First thing, why schedule 2? You got a 2-hour deep dive in the morning. You got a 6-hour, much more controlled deep dive in the afternoon. How many people in this room would like to just do the 6-hour deep dive rather than screw around with this short, which is a very short hydrostatic test without all the safety precautions, without taking time to test equipment as you go deep. And you're also going down at very slow increments in the 6-hour test. Look at this 2-hour deep dive test. We reconstructed this, doing some guessing and looking at the SOSUS but touch any submarine, that's a very quick time at depth. There's no time in there, and they didn't plan to test any equipment. Okay, there was no guidance on what you did during a deep dive test. Closest guidance we can find out is prior to Thresher's first deep dive with Admiral Rickover on board, Director of Naval Nuclear Propulsion. They all agreed that since they all knew the blow capacity was terrible, they all agreed that the trim pump capacity was terrible. So they agreed if you could rapidly accelerate up, maybe you get better flow rate and better blow rate if you got up a couple hundred feet. So leave main coolant pumps and fast to get that acceleration. Except by the time Axine got his third testimony, everything changed. Now, no, fast speed main coolant pumps are no good. Slow speed main coolant pumps are better. And we'll go into that detail later. Slow speed main coolant pumps are just a lot more reliable. Okay, if you want to go fast on a nuclear submarine, you have to have main coolant pumps and fast, or you have to have increased flow through the reactor. But that requires a lot of power. And that power can only be provided by the ship service turbine generators, which require reactor steam. Slow speed main coolant pumps do not. They can be powered off the battery by the ship service motor generators. And they just found that fast speed pump acceleration was just not good. The reliability of the slow speed pump was much better. And so these recommendations came in for deep dive tests, and they kind of got into Naval Reactor's business by saying main coolant pumps and slow speed should be done for deep dive tests. Okay, main coolant pump stopped at 0911. How's the scram? It's called a no flow scram. It's no bueno having no flow through a reactor when the reactor is producing decay heat things. So you gotta scram the reactor, shut it down. And there is no effective backup for loss of propulsion when you're deep if you're heavy. Okay, here's some of the timeline here. Bruce's book talks about 2 minutes of slow variation of main coolant pump speed, which means the turbine generators were slowly varying between 09 to 0911. To me, this is this is a possible symptom of interruption of flow, cooling water flow through the main condensers, which is going to change speed of the turbine generators. That means they've got some kind of problem going on, leak isolation, something spraying, some water is spraying. We didn't find that in our first couple of times to the testimony, and we finally found it because it was very heavily redacted, but that confirms what Bruce Rule said in his book. Now, right after that 0909, when we say the slow variations, some other things start happening. Thresher changes course to the same course as the escort vessel Skylark. Why do you do that? It reduces the chance of a collision between your escort vessel if you're coming up on the same course, right? And they started the main ballast tank blow. But that blow only lasted 90 seconds. Opinion, they were sinking, they were in trouble, and the CO expected that blow to service the submarine. And again, main coolant pump stopped at 0911. Very interesting message at 0913. Experiencing minor difficulties. We'll talk about that. That's kind of a crazy statement to make. Have positive up angle. We hope so. That's what submarines are supposed to do when they're in trouble and they're deep. Attempting to blow, well, the 90-second blow stopped. I wouldn't stop blowing. I keep blowing until I was on the surface. Then we get another, right after that, we get another 30-second blow that stops. 0916 exceeding test depth. We think that's collapse depth, and we'll show you that in the next slide that Fred produced. And they heard 900 north. Not sure of that, but the board really thought, the court really thought that they heard that. Does that mean 900 feet below test depth? That kind of makes sense. And then we have implosion at about 2,400 feet. We just did a paper on this for the submarine review, and 2,400 feet looks pretty good for the actual collapse depth. 22,000 tons of TNT equivalent. Okay. The low 4 gram. We talked about the low 4 grams, or what the SOSUS produces. The paper strip. Okay, Rule has testimony in there. He talks about this exhibit 52. It's a low 4 gram. He talks about that as showing all this very important material. Well, this low 4 gram the Navy just gave us back in November doesn't show, only shows the implosion. In every hydrophone, every SOSUS hydrophone in the entire Atlantic Basin heard that explosion. So that's the president of the court told him to mark an A on that exhibit. There is no A on that exhibit. And there's heavy surface contact, and we'll show you that next. Okay, this is the low 4 gram the Navy gave us with some redactions. It's beam 19, and that's not right. We'll show you that in the next slide. This chart is moving at 13 inches an hour, 0 to 150 hertz down here. All these lines, Bruce said, and it makes sense. That's not a main coolant pump line. That's a bunch of surface ship noise coming through there with all kinds of interference. Bruce said when he briefed that slide, that graph on April 18th, 1963, he was very, very clear. You could see the main ballast tank blows. You could see the main coolant pump line coming down. Not there. Now look at this. This beam 19 is sticking way out here. Pressure wreckage is all the way down there. They're not in the right direction. So you expect, here's a better representation. Here's this beam 19 looking out to sea, picking up merchant traffic, right, going up and down the coast. And here's this end fire beam looking down here towards where the Thresher, and you can see it's not very, that's just wreckage, it's not very, that's all approximate. We have the lat long of the rendezvous point, but certainly not the Thresher. So that doesn't make sense. Okay, depth versus time. Fred assumed that Thresher was 15,000 pounds heavy. a lot of talk in the nuclear submarines. You don't need to compensate for going deep. A 594 class submarine gets 1,000 pounds heavier for every 100 feet it goes deep because the hull compresses. So if they didn't do that, Fred said, well, at 0911, the ship stops and starts to sink. Well, look at this. At 0913, you're down here. Is that a minor difficulty? Not to me as a former submarine captain. I think you're in real trouble. I wouldn't call that minor. Then about 0916, passing test depth, well, unless they went down really, really fast, you know, they're passing collapse depth, 1,950 feet. And then you have the 900 north, and then about works on the timeline. And he did what's your calculation on what do you call this, Fred, this line here?
That line is on the basis of meeting the SOSUS and Skylark UQC communications. It's a trajectory calculated through the depth that the Thresher was passing.
Thank you, Doctor.
Okay, so why did the ballast tank blow fill the surface? By testimony, it should have. And I'll get into that in a minute. But that was the key question that the Court of Inquiry wanted to know. Tenosa, you saw the picture that I pointed out earlier in dry dock, was under construction at the time, and her main ballast tank blow system was functional. So they ordered a pier side blow of Tenosa's main ballast tank blow system, and that was something that had never been done before. And there was a lot of concern about whether they'd blow out the ballast tank shell plating or what would happen. So they approached it in an incremental fashion. When they finally did the full 4,500 pound blow, what they found was that it would blow and stop, and then it would blow and stop, and it didn't perform the way they expected it to. So they broke open the mechanical joints to figure out what was going on, and they found that it was blocked by both ice, and there was a strainer that was a conical strainer that was installed that had collapsed on an orifice plate and plugged it, and then it iced over, and that prevented it from working properly. You can see, in this case, this is off of Tenosa. You can see the tip of the conical strainer and how that got all mashed down. It sat on top of this orifice plate, and basically the mashing of that conical strainer into the orifice plate effectively blocked it, and then you made sure it was blocked by buildup of ice on top of it because Thresher had moist air. By testimony, the ship should have been able to deballast about 10% of its ballast tank at test up, even though it wasn't designed to do that. I calculated that it would take about 100, that would deballast the ballast tanks by about 120,000 pounds worth of water. Should have been more than enough to make that boat positively buoyant and then some to get it to the surface, but it didn't. So what we found was these strainers were on the inlet side of the 4,500 to 3,000 pound air reducers. Remember, I told you that they reduced the pressure down to 3,000 pounds. The strainers ended up collapsing, and they froze in place, and it basically restricted airflow. The testimony indicated that, sure enough, Thresher went to sea with those strainers still installed, even though the shipyard had directions to remove them. And the reason that we know that was the pipe shop was directed by the ship to break those mechanical joints open to prove to the crew members that they were still installed. As Jim said, the new CO had nothing but problems with particulate damage in the high pressure air system because it had contamination, tearing up his reducers and causing leaks. He didn't want to go to sea without those conical strainers and those orifice plates being installed, not knowing what it was going to do to him. So it wasn't like it was a logical reason for him to want to retain him. Unfortunately, it had dire consequences. So as a result, we got a 90-second blow from Thresher initially. It looks like they tried to do it again a couple of minutes later. They only got a 30-second blow. It was a very ineffective blow. They didn't move enough water or enough air into the ballast tanks to displace enough water to get the boat.
Now comes the fun stuff. Nuclear propulsion, Admiral Rickover, yay! I just was interviewed by him. We're talking about how he defended his program and about his emergency procedure. Okay, Rickover goes into court. He wasn't supposed to testify, but he kind of got forced in to go into the court. And they did it publicly. This part was all public. And the judge of the court says, well, Admiral Rickover, of course, the reactor has nothing to do with this, right? And oh, yes, of course. Now he pulls out his prepared speech and says, oh, yeah, well, we'll go later on. Maybe the reactor procedures did have something to do with this. But anyway, he covered that. And the next thing was, we all know this guy. He was created by radiation, right? You know, giant ants, Godzilla's all created by radiation. You see movies, the public has seen movies about this for the last 5 years, 6 years. And so the next answer was pretty good. No, there was no radioactive contamination. And that is good because they did bottom samples and they did air samples and they did water samples. And there was no radiation. So what you're seeing here is protection of the nuclear propulsion program. We had 28 nuclear submarines at sea. We had 36 more either bought or being built. And the only way we could keep the Russians from nuking us, my guess, my opinion, is that we deploy submarines off their coast and nuclear submarines. So nuclear submarines are very important. Okay, here's Rickover's description of his nuclear, his emergency repulsion procedure. When the reactor shuts down, it does not stop producing heat. There's a decay heat factor up to about 10% of what it was produced before the shutdown. Okay, if you read this real quick, he admits here that if they had kept the main steam stops open and used that decay heat, residual heat, they could have got to the surface. And this next one here, he admits basically that he was training the board. He was talking to the board about this procedure, about the repulsion. Well, on the board was a guy named Captain Osborne. He had just been commanding officer and the construction officer of the George Washington, the first SSBN, the first listed missile submarine. Well, when he was on board, he wrote a standing order to leave these steam stops open and to use steam under certain conditions. Like if you're sinking, you get a big down angle, you're going deep, renewable waters. Nowhere in the testimony, none of the papers we've asked for so far have shown this, but no explanation of why Thresher and the rest of the fleet did not have this procedure. It was a well-known procedure because naval reactors had gone out and practiced it on submarines. And everybody knew that remember, a very small community back in those days. So everyone knew this procedure existed. And we don't know that. And this information came off of a friend of mine who was a squadron commander and served on George Washington as a junior officer. Rickover did do some things to speed up the recovery. If you keep steam in the engine room, don't shut the steam stops. It's easier to recover. It's faster to recover because you don't have to warm things up. And he mentioned there's a faster experiment recovery. Rickover was in big trouble because he was in battle with the submarine diesel boat mafia, diesel boats forever mafia. He needed to prevent his program from being damaged. He was replacing diesel electric submarines that just 18 years before were great heroes in winning the war against Japan. And many of those officers, lieutenant commanders who were academically qualified were being rejected by Rickover. And why was that? Because what caused them to win World War II? They were brave, daring. They didn't follow orders. They didn't follow directions, right? They drove their machinery into the ground. Lucky Flucky put a shore party ashore and blew up a train. Rickover knew if he had a major reactor accident, he was going to hurt his program. And he did not want a guy like Lucky Flucky running around his CO of Barb operating his reactor. Now remember, Dean Axine, the first commanding officer, carries a World War II patrol pin in a Bronze Star with a combat V. And then we have now, what I missed here. Smedberg was the chief of naval personnel. He said to the court, "I've given you a big list of people who are academically qualified. They're really smart guys. But it's your prerogative, Admiral. You have reactor safety in mind. I will stay out of that." Not so Red Ramage. Why did Red Ramage take on Rickover? This is his description of the nuclear trained officers that get ready to be XOs and XOs. Not very flattering. Well, why could Red Ravish do that? That little blue ribbon up there is the Medal of Honor. And so he could outgun Rickover, even though Rickover had Congress in his back pocket and all that kind of stuff. So he was not very kind to Rickover. Rickover tried to, I know we're at the end, boss.
Yeah, we're not giving you the signal, so you
Okay, yeah.
wrap up.
Rickover tried to blame other people. It didn't work. And these are our findings at the end. Rickover's comment is correct. Portsmouth Naval Shipyard guys, they were very conscientious during the testimony, very studious. They worked very hard, but they didn't have the procedures in line to do that. And there are a lot of concerns for delay. And this is a result.
Yeah, basically, these are the 129 guys that were lost on Thresher, both military and civilian. There were a number of civilian riders from the shipyard and some of the contractors on board. What came out of Thresher was a program called the Submarine Safety Program, which is known as SubSafe. And basically, the SubSafe program is their legacy. It attempts to fix some of the shortfalls in the design and fabrication and quality assurance that we touched on.
Steve went to school, a lot of their children. Of course,